Good morning, everybody. Today, we're going to start the new unit. And the unit is, I can identify the end behavior of a polynomial function. So starting off, I thought it would be a good idea to go to Desmos. And so if you click on Desmos, it'll take you here. And I just want to make sure that you guys review some of these skills that are here. So the first thing I want to make sure you understand is what's called the degree. And so the degree of a polynomial is the degree of the term with the highest exponent. So remember, like 4 is the exponent, 1 is the exponent. So I would say that 4 is the degree because it's the biggest number. So what is the degree of 5x plus 6x to the 7th minus 8x to the 3rd? I choose the one with the biggest exponent, so I'd say this is a polynomial of 7th degree. Also, putting stuff in standard form, you should put the 6x to the 7th first, and then the minus 8x to the 3rd, and then the 5x. Also, there's something called the leading coefficient, and it's the number that's in front of the highest degree. So for example, the degree of this function is 4, and I would say the leading coefficient is 5 because 5 is the number in front, okay? Now, it's very tempting to jump here and say, okay, 5 is leading coefficient, but that's not true. Okay, you have to look at the term with the highest degree. The highest degree is 7, so the leading coefficient is 6. So that's what we're going to use mostly today. What is the degree? What is the leading coefficient? And that's all we really need to know for today. One thing that's interesting is that notice this is of even degree. Anytime you have even degree, we have something called end behavior. And end behavior is how they look on the left and on the right. It'd be kind of like if I had a book and I looked at the front of the book, and then I looked at the back of the book and I ignored what was in the middle, which you kind of do when you're like trying to decide if you want to read a book or not. Usually you look at the front, look at the picture, you flip it over, and you decide, you know, sometimes you read the summary and you're like, I think I'll check this book out or I'll buy it. So that's kind of what the end behavior for a polynomial is. So one thing that's interesting is if it's of even degree means 2, 4, 6, 8, they do the same thing. So notice these two are both of even degree, 4 and 4, and they open down on the left, down on the right, down on the left, down on the right. Now, when they're of odd degree, they do the opposite. So they go down on one side, up on the other, and we say this is of odd degree because of the 7th. Okay, so here's one, x to the 6th. Okay, and I'm going to put that in this. Notice it goes up and up. So I'm sorting these kind of. Notice this is another one that I would call down and up. Just kind of sorting these so you can see what I'm talking about. You can't see this one if I sort it. So it's kind of interesting because, so you look at the degree, and if the degree is even, notice all 4 of these cards are even, then whatever happens on the left happens on the right. It's down, 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 or up, 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 up. So that is if it's of even degree. Notice 4 is even. 4 is even. 6 is even. 4 is even. So anytime you have a polynomial of even degree, it's going to repeat the same thing on left and the right side. Now, when you have a polynomial of odd degree, 7, 3, 3, 5, 7, whatever happens on the left is going to be the opposite on the right. So notice that these all go in different directions. You have one going down, one going up. Okay. So how do you know? And that's one thing you're going to be responsible for is what do these look like? And that's called the end behavior. So I would say as x goes to the right, it goes up forever. And as x goes to the left, it goes down forever. So that's what we call, instead of saying forever, we use the word infinity in math. So as x approaches infinity, it goes up forever. As x approaches negative infinity, it goes down forever. So that'd be negative infinity. As x approaches negative infinity, approaches negative infinity. Okay, so one thing that is good to know is evens repeat themselves. They're up and up, down, down. Odds are always the opposite. And then the leading coefficient, that tells you what it does on the right side. So negative 4 means it opens down on the right. Negative 3 means it opens down on the right. 2, if it's positive, it opens up on the right. Notice 1x to the 7 is positive, opens up on the right. And so once you determine how it opens on the right, you know the odd is going to be the opposite on the left. So opens up on the right, but goes down on the left. Opens up on the right, but goes down on the left. Goes down on the right, but goes up on the left. See that? Now even, same thing, look at the leading coefficient is 1. So that means it goes up on the right. But because evens repeat themselves, it also goes up on the left. Here, 2 is positive, it goes up on the right. So it also does the same on the left side. Here, negative means it goes down on the right, which means because it's even, it does the same thing on the left. So you look at the leading coefficient. If it's positive, it goes up on the right. Negative, it goes down on the right. And then you look at the degree and that determines what it does on the left. Does it do the same thing or does it do the opposite? So the nice thing about these is there's only so many answers. Like it's either up and down and up, or down and down. Okay, so I found, and I highly encourage that you finish this Desmos out there. There's some really good stuff in there. It's really a good way to learn how to do this material without me just sitting here and explaining step by step how to do everything. But I also found this. I'm going to open it. So the end behavior of the graph describes the value of the function. And we say x approaches infinity. That's what that symbol means, approaches. We say it goes to the right, and this is the way to say it goes to the left. And we look at the degree and the leading coefficient to determine the end behavior. Okay, and you all have access to Desmos. You will probably have access to Desmos on the unit test. So if you forget, you can always just go type it in and see what it looks like. So this kind of summarizes what I was talking about. The leading coefficient, it's either going to be positive or negative. That's the only choice, positive or negative. If it's positive, the right side will go up. If the leading coefficient is negative, the right side of the graph will go down. Now your degree is either going to be even or odd. That's the only choices. If it's even, then the left side and the right side are the same. If it's odd, then the left side and the right side are different. Okay, so this chart kind of summarizes, if you have even degree, positive leading coefficient, this is what it looks like. Even degree, negative leading coefficient, that's what it looks like. And so odd, positive, this is what it looks like. So that's a nice little table. So let's determine the end behavior. So first, the person is, I don't know if I could do this on, so the person is just arms. I can't use I don't have enough room for my arms. Okay. So we have to determine what it's going to do on the right. Okay. Is this the right side or is my camera flipped over? Is this the right? Is this the right side? That's the left side? This is the left side? No. Well, that's right. Well, I'm not even going to try because I wish I could reflect my camera real fast. I think there's a way. Okay, so yeah, everything is flipped. That explains why my Chiefs thing in the background is flipped. Okay. I'm not going to try because I'm going to get confused left and right. But I think my cursor, this is to the right. You can see my cursor? Yeah, okay. So I look at this, and that's really all I need to see. Because the 4 is positive, the right side goes up. That's why the guy is holding his right arm up. And then he sees the degree is even, 4. So then he puts his left hand up. So he knows it goes up and up. And so here's how you write that in math. As x goes to the right forever, then the function goes up forever. That's what that says. As x moves to the right, it goes up. That's what that says. Okay. Also, as x moves to the left, as x goes to the left, that's negative infinity, then the function goes up forever. So that's how you write that. Okay, and then this function p of x, functions all have different names. So this function, they're calling p of x. Usually you see that written as f of x, and all that is it's just a way to name the function. So it's kind of like y equals. Here's another example. So I have this polynomial. I identify the degree. I make sure that this is written in standard form. So here is my degree, or my leading term, 3x to the 7th. So I look at the 3, which is called the leading coefficient. That's positive, so the right side goes up. So I would say, as x goes to the right, then the function goes up. That's how you write that. And then I identify that the degree is odd. So if I went to the right, odd's going to do the opposite on the left. So it's going to go down. So that's why his hand is down on one side, up on the other. The way you write that, as x approaches the left forever, it goes down forever. So you can kind of think of this first part as left and right. As it goes to the right, as it goes to the left, then this goes up, this goes down. So it's a fancy way in math of writing this. And I will say on the district assessment, this is how they write it. So you have to become familiar with the notation. All right, here's another one. The common mistake I see is kids always just pick the first term. Sometimes these things are not written in order. So It just so happens that this slide is written in order. So I have negative 2x to the fifth. Negative 2 is, so that's negative. So my right arm goes down. So then I would say as x goes to the right forever, then the function goes down. That's how I say that in math language. Now the degree is odd. So if my right arm went down, well, odd means that it does the opposite on the left. So my other hand's going to go up. So it's going to go up on the left. So I would say as x goes to the left forever, it goes up forever. Lots and lots of examples. Here, negative leading coefficient. So that means right arm down, but it's even, so it does the same thing on both sides. So if the right arm goes down and it's even, then the left arm needs to go down too. And so it's down and down. So down and down. Notice these will always be the same as x goes to the right, as x goes to the left. But really what you need to fill in is this part. Okay, and in case you didn't get all that and you want more practice, notice there's more practice there. I don't want to go over every example in here, but there are so many examples. And so let's go look at the practice together. So here's your practice. And notice they have the summary here. They have a table, even degree. So this is all even degree. Notice it's either up, up, down, down. And then they have odd degree, which is whatever happens on the left and right are different. And then they talk about the leading coefficient. So if you have a positive leading coefficient and odd degree, then it goes up, down. So this table kind of summarizes. So if you're confused on the notation and you're like, okay, I know that I have a positive leading coefficient and it's odd degree. How do I write that? So this is how you would write it, okay? So if you understand the picture but not the notation, that's what you would write. But the function depends on the function name. So I'll do one with you. So describe the end behavior of the graph by completing this statement and sketching arrows. So I look at this and I say, okay, which one is the leading term? The leading term would be the one with the highest degree. Sometimes these are not written in order, so I'd circle this one. And then I would say, what is the leading coefficient? I'm just going to call that LC. The leading coefficient is -1, which equals negative. So we have a negative leading coefficient. That's a -1. Now what is the degree? The degree is 6, which is even. Okay. Now, if the leading coefficient is negative, I like to fill in what it does on the right first. This is what it does on the right. As x moves to the right, the function is where this is where the leading coefficient goes. So it's going to go down forever. And this arrow, their arrows are kind of funny, but this is supposed to be an arrow, okay? Now, once you fill this in, the other part's easy. If the degree is even, it does the same thing. So if I put a negative infinity here, I need to put a negative infinity there. Now let's say I just confused you And you say, okay, I know. Let's draw the arrows. Negative means it goes down on the right. All right. Negative means it goes down on the right. Even tells you what it does on the left. So even, it repeats itself. So if it goes down on the right here, it goes down on the left. And then what you could do is you could go match it up with the picture, down, down, which you won't have this picture on the district assessment, so be careful. But down, down is this one. Down and down. So then I would choose this one, which is exactly what I wrote. Okay. All right, so I don't really have that many practice problems for you, but so we have those 4. Actually, I'm going to go back to so down here, and I also found this video. He does a good job explaining the same thing. And you have a practice and an end behavior quiz. Let's go look at that practice together. So this first part is just a summary to help you out. I already did number 1 with you. So really, this homework shouldn't take any time at all. You're either going to put infinity or negative infinity in both spots. And then there's also something called a relative minimum and maximum. So I'll let you read that. And they teach you how to use a TI-83 calculator to find the relative min and max, but you probably don't have one of these, so feel free to just use Desmos. Okay. And I thought, yes, and then there's also, don't forget these. So these are really how they tend to look. Notice, like on these kind of problems, they're not written in order, so you can't just look at the first number. So like the degree here is 3, so you have to look at negative 3x to the 3rd. On this problem, this is not in order, so you have to look at the 3x to the 7th because it's the highest degree. Okay, so you have to look at the 7. So all I need is end behavior. And then one thing you could do is if you go to Desmos, when I'll type the 1 in we just did together, it was negative x to the 6th plus 4x squared plus 2. So what I said is as x approaches and as x approaches negative infinity, it goes down forever. And as x approaches positive infinity, the function goes down forever. Okay, so that's a good way to check it work. It went down, down, so you should have negative infinity and negative infinity. Okay, now notice if I change this to a 7, then it's going to go up on the left. But we know it's going to go down on the right no matter what because of the negative leading coefficient. No matter what I change that to, it's still going to go down. It's always going to go down. But as I change this degree, it either repeats itself on the left, even degree, or does the opposite. Repeats itself, down, down, or does the opposite. So the degree just tells you, is it the same answer on both sides, or is it the opposite? And the leading coefficient tells you what it does on the right. So like if I made this a positive 6, it's going to flip this whole thing, and this is going to go down, that's going to go up. Watch. Boom. Okay. Because it went up on the right, but then the odd makes it do the opposite on the left. Very interesting. So the thing that the homework was talking about was relative min and max. So we would call that a relative maximum And the reason why that's called a relative maximum is because it's not really the maximum because it goes up forever, right? So it's not really the tallest point, but it is a point at which it changes direction. So it's going up, 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 and then starts going down. So we call that a relative maximum. And then right here, we have a relative minimum because it's not really the minimum. It goes down forever on the left. Okay, but if I had this, say a 12, then that is, of course, the minimum. So relative just means it's not really the minimum or maximum, but it is a point at which the graph changes direction. It's called a turning point. So that's all I have for today. I just wanted to make sure you understand end behavior. I know it is a simple skill, but some kids do struggle with it. So you may need to go back and watch this video. I'll make sure I publish this. Anyway, have a good day, and it's nice seeing you all.